Alrighty, welcome everyone, week 10, last tutorial of the fall semester. This week we're going to be learning about other web technologies that we haven't covered in the past 9 weeks. Let's just dive right in. So the first category of technologies is CSS frameworks. So CSS frameworks are essentially a tool that allows you to write CSS without writing raw CSS files. So there's lots of examples like Bootstrap, Mantine, Boma, MUI, Material UI. They all are essentially styled components. So what they do is you add a class and you install it first, and you add a class to your tag, and then it will have pre-styled components for you. So for example, if I go to the popular one, you Google Bootstrap, you see that you can install it with npm, or you can install it via the CDN. And essentially they have a bunch of layouts, content, components, form stuff. For example, if you want a button, you just add a class of btn, and then you have a bunch of buttons. And of course you can also style it to various types of buttons, like button primary, secondary, success, and all that fun jazz. So one of the major criticisms of Bootstrap or other component libraries is that when you use them, the websites sort of look the same-ish. So if you want a sort of more customized look, these component libraries are not so great. But if you just want to spin up something that looks half decent and not like super ugly, but you don't want to spend the time to do all that CSS, tools like this are very popular for that. So other ones, Mantine, Boma, MUI, they're all pretty much the same thing with slightly different philosophies. Tailwind is also another CSS framework, but I separated it out because it's a much more popular. I wouldn't say much more popular. It's quite different in the sense that it's utility based. So instead of writing a class that represents a button, essentially you write a class and that class represents one line of CSS. So essentially it's an easier way of writing CSS that's faster and inline. Goodness. When website, you can see that there is a bunch of utility classes that you could use, and each utility class pretty much always maps to one line of CSS. So if I go, for example, if I want to change the width of a specific element, I just search width, and you can see here that we have these classes. So for example, class -0 is a width of 0, class of w-1 is a class of width 0.25 rem, right? So each utility class represents one line of CSS, and what you essentially have is a bunch of short inline CSS on your HTML, and you don't have to write CSS on a separate file. So Tailwind is very, very popular, and it's very it saves a lot of time. TypeScript, another huge technology in web development. So TypeScript is a superset of JavaScript, and what it essentially is it adds typing to JavaScript. So JavaScript is kind of like Python in the sense that the types are sort of dynamic, meaning you could change it, you could even assign things to non-existent things. You can do all sorts of crazy stuff, and the editor won't warn you. And if there are any errors, it will happen on runtime instead of on compile time or on when you're writing. And so TypeScript essentially, it does strict type checking, kind of like Java. If you've done Java before, it allows your editors to do lint type errors and suggest object fields. So for example, if you have a class of person with age and name fields, you put a dot, and then it will suggest those fields for you. JavaScript does not allow that. TypeScript is not supported natively on the browser, and so when you write TypeScript, you have to compile it to JavaScript, and then that JavaScript can then run on the browser, which is kind of annoying, but the compiling process makes it so that, first of all, the compiling process itself is a type checking, but as well, you can also compile to earlier versions of JavaScript. So there are evolutions of JavaScript, the ECMAScript standards, that change every once in a while, and older browsers will still sort of not support the newer versions of JavaScript. So if you use TypeScript and you compile it back down to JavaScript, you have the option to essentially compile it back down to the older versions of JavaScript, to support older browsers. So it's sort of to kill two birds with one stone in some sense. So if you look in the TypeScript docs, you can see, and I'll show a little demo. But if you look in the TypeScript docs, it's pretty self-explanatory what it does, right? It lints, and linting is just a little red squiggly line. And for example, when you access something that doesn't exist, it will warn you. So the easiest way to showcase this is to just go to the editor. Now, luckily, how your editor works is your editor essentially has in the background an LSP, or language server protocol, or a thing that follows the LSP. And that program essentially reads your files statically, so it just reads the text and then sort of analyzes them and then lints them. So you have to install TypeScript technically on your editor, but if you're using VS Code, it just supports it out of the box. It's owned by Microsoft, TypeScript is owned by Microsoft, VS Code as well. So if you have a, for example, index.js, let's say I want to create an object that is person, and then first name is equal to John, and age is equal to 72. And you do console.log person dot whatever, there is no warning, right? You can just access whatever you want, and there's absolutely no warning sign whatsoever. In fact, you can access even deeper to that, and there's just absolutely nothing that warns you that this is not a thing, even though when you statically analyze what's written, you can clearly see that that does not work. So if you do, oopsies, where am I? Tech demo. If you do, if you run it, it will say, okay, I cannot access properties of undefined because person.this is not defined. But if you change this to TypeScript with a .ts, it will then warn you and say, okay, you can't do that because I've statically analyzed the code, and I know that this does not exist. And of course, TypeScript works across files, so if you write multiple TypeScript files, it will still work. And this is just the beginning. Like, you could do a lot of things with TypeScript. One of the most important things you could do is to create interfaces. So for example, I can create an interface. An interface is essentially like a class, and it defines a set of fields and their types. So for example, I could do interface person, and I'm capitalizing this because it's kind of like a class. And I can do first name. So every person needs a first name of type string and a age of type number. And from there, I can actually use this type. So I can say const person. If I retype this, const person, and then I can specify that this is of type person by doing this. And then I can assign it to an object. And if it's an empty object, it will say, okay, you're missing certain fields, right? So I can say first name. And you can see here that it hints, right? I didn't even finish typing it, and it hints. It sort of knows what you're about to type. And I can do, if I do a string, and then it will still say age is missing, right? So I can do age 24, and now it will stop yelling. Let me delete this. And if you do something that's not of the same type, it will warn you. String is not assignable to type number, and stuff like that. And of course, when you actually go and access properties of that person, you'll have type hints. So this is all TypeScript, and it's built into VS Code. VS Code just supports it out of the box. And most production apps out there that uses JavaScript use TypeScript. So it's very, very standard, and allows you to essentially catch errors faster, and allows you to write code a bit safer. So that's essentially how TypeScript works. And it's a superset of JavaScript, so that means every JavaScript code is just valid TypeScript, but not vice versa. All right, so there's also ESLint and Prettier. So ESLint is essentially a linter, kind of like TypeScript. TypeScript is kind of like a language, kind of, a compiler, a language, a linter, a lot of things. ESLint is just a linter. And what it does is it sort of lints certain things that are not following convention. So there's lots of things that you could write in JavaScript that are not sort of, well, you can write the same thing in different ways, right? So if you go to well, it doesn't matter, I'll keep this. If I go write a function, right? You could either write the function like this, right? Or you can write like const equals to an arrow function, right? These are all like fine syntaxes. And of course you can either use double quotation or single quotation, right? So there's lots of ways you can do the same thing. And what ESLint does is essentially standardizes it. So you specify that, okay, I want this entire code base to just write functions this way or this way, or I want this entire code base to have double quotations or single quotations. So, and if you don't follow those rules, it will lint for you, right? So that essentially allows you to have a more consistent code base. And Prettier is very similar. ESLint is more for linting. Prettier is more for formatting. So there's lots of ways to format stuff. If you have very messy HTML and it's not indented properly, you're gonna kind of have to like manually format it and indent the elements. Prettier does that for you. So, and of course these are built into the editor. Not by default though, you have to install them in the editor as an extension in VS Code and actually install it with npm. So these are also very popular tools that a lot of people use. And of course, there are other JavaScript frameworks available. We learned about React, but there is a very lot of JavaScript frameworks out there. And the three most popular alternatives, Angular, Vue, and Svelte. Svelte is less popular. It's sort of more modern, but Angular is quite old. Angular is actually older than React, I think. And it's created by Google. And they actually have a pretty amazing website, last I checked. Angular is essentially a, wow. Damn. Yeah, it's essentially a JavaScript framework that does exactly what React does. So if you think about what React does, Angular is just exactly the same, except with different syntax and slightly different philosophies. It's more used in, well, I wouldn't say it's more used, but it's definitely used quite a bit in the industry before React was a thing. I personally have never written it, and it doesn't look very pretty, but if you liked Angular, that's fine. And there's also Vue. Vue.js is open source, and Vue.js is essentially the same thing as React. It does the exact same thing with slightly different syntax. I don't know too much about these JavaScript frameworks because I don't personally use them, but they are extremely popular. Vue is sort of, from what I can see, it's sort of targeted towards simplicity and not a lot of code. So you often see that Vue.js looks a bit cleaner than React. Angular doesn't though. And Svelte, same thing. Svelte really emphasizes on simplicity, and its philosophy is sort of they want the syntax to look more like vanilla JavaScript, well, HTML, CSS, and JavaScript. So they really want everything to be looking exactly like, without a framework. Like, so you write JavaScript in a script tag, you write buttons like a regular button, you write styles like a regular style, right? It's very much sort of, it looks very vanilla, but it actually does a lot of things under the hood to actually allow these things to work nicely. And of course, there's a lot of like extra stuff like this. And this, you can imagine this is just state, right? Kind of like use state in React. So yeah, lots of alternatives, but React is by far the most popular and definitely used the most in the industry, and would definitely recommend learning that before the other ones. Yeah.
So there's no practical reason for moving one or the other, just personal preference?
It is personal preference. If you want to explore more, definitely do that. I personally don't know much about the differences. When you learn more about it, I guess you can sort of tell the philosophical differences. But essentially on a technical level, there is no difference. They do the exact same thing. And because of that, after I learned React, I just never bothered learning anything else because they just do that. And it's far more popular anyway, so I'd much rather spend my time learning about other things. But these are alternatives that essentially do the same thing as React. And then there are also full stack frameworks. So full stack frameworks they're kind of, they're essentially tools that allow you to build both the front end and the back end with one thing. And an example of this is like Ruby on Rails. Django kind of does this. Express can kind of do this if you add it with a template engine. But essentially how these things work is you have essentially a web server, so that's the backend, and this web server can communicate with the database, it can call APIs with secret keys, do all the stuff that backend servers do, but also what it can also do is sort of fill out HTML templates. So for example, you can write an HTML and then fill in those like little gaps with data and then send the HTML as a response. So instead of just sending JSON as a response, like how you would just backend server, these full stack frameworks allow you to sort of send back HTML as a response, and you get that content directly from the web server instead of having to render it on the browser or have it sort of pre-written. So very powerful stuff. JavaScript meta frameworks are essentially the same thing, except more modern, and it's written entirely in JavaScript. And these meta frameworks are essentially, in many ways, wrappers of essentially like JavaScript frameworks that we just spoke about. So, for example, Next.js is kind of like a wrapper. It wraps around, it uses React under the hood. Nuxt.js uses Vue under the hood. SvelteKit uses Svelte under the hood. Angular, there's none because Angular is kind of like a meta framework itself. So what they allow you to do is essentially write JavaScript framework code, so like how you'd write React or Vue or Svelte, but with extra features in the backend. So it allows you to sort of do backend stuff, like fetch from the database or do server-side rendering. Very, very similar to how these things work. This is sort of older. This is sort of newer. And this, you sort of like send back an HTML template and then write vanilla JavaScript maybe. But, And these, essentially you can write React or whatever code, like Vue or Svelte, along with backend code. So it's much more streamlined that way if you want to use a JavaScript framework. But because of that, it's also much more complex. So you have to understand the fundamentals before using these tools. So for example, to use Next, you kind of have to understand React. And to understand React, you kind of have to understand JavaScript and HTML, CSS. So these are sort of tools that are very, very powerful, but also kind of confusing if you're just starting out. Would not recommend using them to learn, but these are very, very powerful tools that you can use to sort of build applications faster. There's also Gatsby and Astro. They're grouped together because they're of the same sort of type in the sense that they are essentially frameworks that allow you to generate HTML, CSS, JavaScript. Instead of writing HTML, CSS, JavaScript, you can sort of write code that doesn't look like that. For example, with Gatsby, you can write React, and even though it looks like React, it essentially compiles down to just plain HTML, CSS, and JS. And of course, Gatsby also has a GraphQL data layer. I'm going to talk about GraphQL in a bit, but Astro is very similar. Astro allows you to sort of build websites with React components, Vue components, Angular components, well, maybe not Angular components, but Svelte components. And even though it looks like they are components, they are actually just regular, they eventually get compiled into regular HTML, CSS, JavaScript. So if you want to write a website that's just content, these are very, very powerful tools to use. And of course, there's headless CMS. So what we built is actually pretty much, like the server that we built with Express is pretty much just a headless CMS. So it essentially is a web server that fetches content from the database and then sort of serves that to the front end. So headless CMS are essentially industry tools that does that. And so three biggest examples is Contentful, Strapi, and Sanity. And yeah, they essentially do exactly what we just built. They have an admin panel and you sort of edit the content and it sort of updates on the front end. So not much special there. And they're headless in the sense that they don't have sort of regular, so they only take care of the content side of things. Regular CMSs, content management systems, they have, so for example, WordPress, they cover the content, but also the presentation, right? It's for people who don't know how to code. But for headless CMS, it's sort of just for content, and you have to sort of code the entire view layer, the whole sort of presentation layer. And so headless CMSs are much more flexible, and they're a great option if you know how to code, you want a very customized look, but you also want a non-coder to be able to edit the content through like an admin panel. There's also GraphQL. GraphQL is essentially kind of like REST APIs. So it's another way of fetching data, but except the difference between this and REST is that with REST, you either fetch everything or you fetch nothing, right? You either fetch, if you want to fetch the content, you fetch all of the content. With GraphQL, it allows you to sort of fetch part of the content, like certain attributes of the content. So it sort of prevents overfetching and underfetching. There's also React Native. So React Native, we're sort of diving off a little bit off of web development now, because React Native is essentially a way of writing mobile apps with React. So React is actually not a web framework per se. React, the core of React is essentially an algorithm that allows you to calculate the states and views of a application. So it can actually be applied to other things as well. React DOM applies it to the web, but there's also React Native that applies it to the sort of native components in Android and iOS. So you can essentially write React-like code without the HTML elements, but like the HTML elements are essentially like elements or components within the like building blocks of the iOS or Android app. And but everything else is the same. You can use effect, use state, use hook, or use all sorts of hooks. And popular React Native apps: Instagram, Facebook, Airbnb, Skype. So it's very, very popular. And so if you learn web development and you know React, it's a great option. And that's another reason why learning web development is quite crucial, because not only can you use that skill for building web applications and websites, you can also use that skill to build mobile applications, which is the ranking sort of goes web app and then mobile app and then desktop app in terms of like, you know, the modern, you know, ecosystem. So that's possible. Now, React can also write desktop applications. So it can build on the web, on mobile, and it can also build on desktop. So essentially the same thing. You can write React code, and it will. You can think of it as like a sort of like a mini browser. And so you write HTML, CSS, and JavaScript, and it will sort of get rendered on the app. And it essentially uses Chromium under the hood, right? So it is kind of like a browser under the hood, but it allows you to build like app-like experiences. So you can access the file system, turn on the camera, you know, access GPS, all sorts of things. Popular Electron apps include Visual Studio Code and Discord and a lot of others. Electron is sort of the major criticism is that it like takes up a lot of RAM, and that is true. And if you're building small applications, I don't think that matters too much. But the reason why a lot of modern desktop apps are built with Electron is because it's just easy, and you just have to maintain a code base that's extremely, that's essentially the same as if you were to build for the web. And Electron, I believe, also allows you to compile to web and desktop. So you can really manage multiple applications in one code base. And a lot of really advanced applications like VS Code use Electron. So it's pretty big stuff. So there's also Docker. Docker is a bit more complex, but essentially what it is it's a tool for isolating development environments. So when you build an application, there are dependencies that you may have. So for example, this application depends on other packages, and those packages depend on other packages, and it sort of depends on everything else that's below it, and then all the way down to the operating system level, right? So there are cases where when you write your code, it sort of works on your computer because you have the necessary dependencies on your laptop, because you have it installed, or your operating system works well with it, whatever may be the case. But if you ship this code onto the cloud, onto the servers that you're deploying, or onto other people, they may not be able to run it properly because they may not have the same operating system as you. They may not have the same binaries as you. They may not have the same environment variables as you. They may not their environment for executing that code is just not the same. And so Docker is a tool to solve that issue. It's sort of essentially how it works is it provides a platform for Docker containers to run, and containers are essentially containerized applications. So you can containerize your application and it will become a container, and then that container can then run on Docker. So anything that has Docker installed will be able to execute Docker containers. So you can essentially build your app, containerize it, and test it on Docker. And if it works on your Docker, it works on every other machine's Docker. So it's kind of like a virtual machine, but the difference is that VMs are more heavy, Docker is more lightweight. Now, of course, the VM offers even more isolation, but oftentimes Docker is pretty much enough. So not a tool that you have to use, but definitely something that you have to at least understand what it's for and that it exists. There's also backends as a service. This is one of my favorite tools, actually, or favorite types of tools. And backend as a service is essentially a tool that essentially writes your backend for you. So you don't have to write any backend. All you have to do is just focus on the front end experience. So if you think about what a backend does, it often does very, very similar things. No matter what application you're building, it often communicates with the database. It often sort of handles authentication if you have authentication. It calls APIs with secret keys because you don't want to call it with those secret keys on the front end, obviously. It stores files. Like if users upload an image, you want to store that file somewhere on the server. And of course, it executes backend logic and just executes code. So a lot of those commonalities can be sort of abstracted away into one tool, and that's essentially what backend as a service does. So examples are like Firebase, Supabase, Pocketbase, AppWrite. They're essentially all sort of very, very similar functions. They provide for you a way of authentication, database, calling APIs with serverless functions, and functions are essentially you write the function and it will sort of execute, and you don't have to manage like a long-running server. So there was essentially spin up a quick server, run your code, and then just spin it down, right, on scale, instead of like you renting one machine and then just constantly executing the code, which costs a lot of money. And of course storage as well. And so backends as a service essentially allow you to build the front end and then use other people's backend essentially. And so you don't have to write the backend yourself. And so it's a very, very nice way of just very quickly just building an application if you don't want to manage all the the server bills or all the logic that's involved in these very, very popular use cases for backends. And your users will never know. So my recommendation with all these technologies, just my opinion, is that you have to understand the fundamentals first. So the 6 things: HTML, CSS, JavaScript, that's front end. React as well, that's 4 things on the front end. And then learn how backend works, so like things like Express, how to create APIs, how to fetch from the database, how to run backend logic, stuff like that. And of course understand how databases work and how you can fetch from them and so on and so forth. And so once you understand these fundamentals, the rest is really just built on top of all that. There's not really much more like new. So 3 tools that I would highly recommend you use pretty much all the time. You can never really go wrong with TypeScript, Tailwind, and Prettier. So TypeScript, again, is very, very popular. It's very, very standard. And there's the only cost is that you have to learn it, obviously, and you have to actually understand it, or else it will sort of be in the way of you programming. It can sometimes be a bit annoying, and you will sometimes feel like maybe I just should have used JavaScript, but it will pay off in the long run when your code base is become really, really big, and it becomes extremely hard to sort of guess what these objects shapes are and stuff like that. So would highly recommend TypeScript. Tailwind is a very, very low level CSS framework. Other CSS frameworks kind of do a lot for you, and so they're more opinionated. Tailwind, essentially, like I said, it has classes that map directly to one CSS sort of property. So because they're so low level, they don't really have a lot of opinions. They have like sensible defaults, but other than that, it really isn't much. It's really just an easier way of writing CSS without finding coming up with an ID name or a class name and then going to another CSS file and then selecting that name and then styling it. Tailwind just does all that in a much faster way. Prettier is pretty obvious. There's not much to explain there. You got to format your code. I would always recommend building projects and If you want to learn a certain technology that I just mentioned, go ahead, just use it and learn it. And so if you're building just to learn, then just do that. It's pretty obvious. But if you're building to actually build, like if you actually want to get something out there and use the right tools for the right job, it'll depend on what you're building. If you're building a website with little to no interactivity, so that's essentially like websites that just displays content. There's not much, it's not a web app, it's not like really an app. Then I would highly recommend you use things like Astro and Gatsby. Or you could use a headless CMS if you want, or you can hard code the content, it doesn't matter. And of course Next.js as well, because Next.js allows you to do pretty much everything, to be honest. And Next.js allows for SSG. And why? Because a website needs to be fast, needs to be SEO friendly, needs to be fast to build, so no extra complexities, and content driven. So these are all tools that allow you to do that. If you're building a client-side application with no backend, or maybe if the backend is already built for you, like the backend is already ready and you just have to build like a dashboard that sort of displays and wraps around that backend, you could use React or other JavaScript frameworks, and they're essentially apps on the web. So there's no need for extra complexity, and it's very easy to develop and add a lot of interactivity on the front end. If you build any sort of complex web application with vanilla JavaScript, you're not going to have a fun time. But if you're building a full stack application, so this is like essentially everything, you would want to use a meta framework or a full stack framework that covers everything from the back end to the front end. So stuff like Next.js, and of course, if you want to use a backend as a service, you could do that too. Next.js is Firebase. It's a great stack. And when I say stack, I just mean like tech stack, which is essentially your tech stack is the set of tools that you use to build your application. So Next.js plus Firebase is definitely a really good way of writing full stack applications. And it's also really, really fast to develop and has literally all the features that you need. There's not much that, you'll notice a pattern here that Next.js is sort of in everywhere, because Next.js can kind of do everything, to be honest. You can never go wrong with Next.js. But you have to kind of understand it, which is not easy. So those are just my recommendations. Of course, you can just go do your own thing and build whatever you want. But I will say that it doesn't make too much sense to build a regular website, like for a client, like for a company, or for a for a club, in just React. It's not very fast. It's not very SEO friendly. It adds just extra unnecessary like complexity, because you barely use state because it's just content, and so it's kind of unnecessary. So that's basically it. There are also additional resources available online. So I bolded 3 because personally that's how I learned web development. I know pretty much nothing about web development in first year, and then I learned a lot of what I know, pretty much everything that I know now from like 4-6 months of just grinding through these resources. So primarily it's 3 things. YouTube, which sort of give you bite-sized information about certain things, but they don't really give you a comprehensive view of everything that you need to know. For that, I would recommend these 2 platforms, the Odin Project and Udemy. Udemy, there are sort of, for me, I learned web development through a full stack course on Udemy, and that is, I think, in total 70 hours, and that covered a lot of the fundamentals. The Odin Project is more reading instead of video based, so I find it kind of hard to sort of focus. I much prefer a video. But the Odin Project has a lot of, it also dives deep on the fundamentals, and if you actually finish the Odin Project, there's not much more you need to know in terms of the fundamentals. You'll be very set. So it's very, very in-depth. But it guides you through a lot of readings, and you have to do a lot of readings, and if you're not a fan of that, then that's not good. But it's also very project-oriented, and so one of the major things I would highly recommend when you're learning web development is to build. There is no other way of learning other than to build. So whether you're doing it through YouTube, the Odin Project, Udemy, or any of these resources, you have to build. You have to create your own project, because you're going to run into problems and you're going to learn how to solve them, and then you're going to have a sort of more comprehensive view of how these things are built from the ground up. And again, learn the fundamentals. Don't jump to the more fancy stuff. The more fancy stuff is not as good as you think. They also take a lot of time to build. Or if you use them, it takes a lot of time to build. So other resources, Full Stack Open. I haven't used it, but I heard it's good. Free Code Camp, Code Academy, Coursera, Roadmap.s. It's not really like a set of tutorials, but rather a roadmap. So, road.sh, roadmap.sh. So it's essentially a set of roadmaps for everything that you, for all the fields that you want to get into, essentially, in development. So again, this is kind of outside web development, but a lot of this is web development. A lot of software development is web development you're going to learn. There's role-based roadmaps, there's skill-based, there is project ideas, tons of things that you can go over. So, if you just want like a comprehensive view of everything that's available, it's here. So for example, let's say I want to be a front-end developer, you click in here, and it sort of tells you all the things that you need to learn. And this is just scratching the surface, right? There is tons of things you can learn about web developments and application developments in general. But just the front end, you can see that there is an absolute mind-boggling amount of things to learn. But the tutorials that I've went through, they cover a majority of these things, right? So I didn't cover the internet, but HTML, CSS, JavaScript, right? And then I went through Git, right? And GitHub. We went through npm. We went through these JavaScript frameworks. We went through CSS and these tools like Tailwind. Preprocessors I didn't really go into. We talked about build tools like ESLint, Prettier, and Vite and stuff like that, right? We talked about cores, HTTPS. We didn't talk about web components, but we talked about TypeScript. We talked about SSR with these meta frameworks, right? So, there's a lot of stuff, but there isn't a ton in terms of the fundamentals. They sort of follow a pattern. And if you go to the back end, it's quite similar. Back end is a bit more complicated because you learn sort of SQL. And by the way, if you're learning a database, would highly recommend you learn SQL and not Mongo. Mongo is more user-friendly, but SQL is used a lot more. But it depends on your goal, I guess. So tons of things that you can learn. A lot of these things I don't even know, like Neo4j or Base. Like I don't know any of these things. And so, or if you want to be an Android developer, right, there's roadmaps here, and tons of things. Even specific frameworks themselves, you can dive deep on it. For example, with React, you can dive deep on a lot of things. And the React ecosystem is absolutely massive. So tons of things that you could look into here, and tons of So it isn't just these tutorials, but it isn't just YouTube either. You're gonna find if you just learn through YouTube, it's a lot of bite-sized information that you won't really get a comprehensive view of everything. So try to follow through a course. And unfortunately, the school system doesn't really teach you these stuff. They teach you more theoretical stuff, which is fine, but they're not that useful in building applications. They're not that. Just my opinion. Professors won't like me saying this, but whatever. They're not very helpful in getting you a job either. So that's the unfortunate fact of how it is right now, unfortunately. So, but you're gonna have to do a lot of self-learning if you want to be a software developer. That's just kind of how it is. Like, I think forever. So yeah, that's pretty much it for all the tutorials. I'm